So, okay, so we should be recording. Mic is on. Let's see if we can do this. Okay, so it says to verify the identity. Okay, so first thing I'm going to do, y'all, is we have a formula that says the cosine of 2 theta is equal to cosine squared theta minus sine squared theta, right? Okay, so let's take a look and see if we can't figure something out here. I'm going to do a little stare and compare. I want you to look at this, and I want you to look at this. Isn't this telling me that 2 theta is kind of the same thing as 4x, right? Okay, so if I were to apply this formula, but using this here, then what I would write here, I would write cosine squared of 4x minus sine squared of 4x, right? And I'm just trying to see if there's anything I can come up with here, okay? Yes, but yeah, so I'm sorry, you know what? Maybe that's what I'm trying to do. So yes, if 2 theta is 4x, you're right, John, sorry about that. Then theta is going to be 2x, right? So I'm going to put a 2x here and a 2x right there. Does that make sense so far? We're good? Okay, so remember, I'm trying to get this piece here to look a lot like that piece, right? And we're almost there. The only difference is here on the left side, guys, we have cosine to the fourth and sine to the fourth, and here we have cosine squared. So let's see. I'm going to just come over here to the side for a second. One of the formulas that we've talked about before is that difference of squares formula. A squared minus b squared equals a minus b, a plus b. Okay. Now, guys, this formula here can be applied to anything that's subtracting squares. If my powers are even, then they really are squares, right? It's 4 is the power of 2 being squared. You know what I mean? It's the power of 2 being multiplied by 2. So I'm going to do that here. Okay, I'm going to think of this as my a squared and this as my b squared. So when I use my a minus b and a plus b formula, I'm going to say this is cosine squared of 2x minus sine squared of 2x times cosine squared of 2x plus sine squared of 2x, okay? Again, remember what I'm trying to get to. I'm trying to show that this piece here and this piece here really are the same. Sir, sit over here. You're not wearing a mask? Don't sit next to somebody if you're not going to wear a mask. Okay, what is cosine squared plus sine squared always going to be equal to? 1. Since this piece here is going to be equal to 1, don't we have the same thing on both sides? And now I'm done. Okay, so now look, let's take a look at what we did. Where did this one come from? Because I kind of lost track. Okay, remember the Pythagorean identity, cosine squared theta plus sine squared theta is equal to 1? Isn't that what I really have right here? Didn't we say earlier that theta was the same thing as what? As 2x? No. I'm saying that this piece here is going to cancel out to the number 1, right? So far am I doing okay? Okay. So now the question is, how am I going to do this on Alex? So look, I'm going to stop sharing this so y'all can see it on the video. And let's go over here and let's come back to, I think this is the problem. Here we go. Okay, so look what side we're working with, right? So remember what we did when we worked it out? Didn't we use our a squared minus b squared formula to break that piece up? So what I'm going to do here, y'all, I'm going to rewrite this as cosine squared of 2x, oops, 2x minus sine squared of 2x times cosine squared of 2x plus sine squared of 2x. Okay, and so what rule am I using here? I'm using algebra, right? It's just the difference of squares formula. Okay, so now I'm going to go validate. Okay, now cosine squared 2x plus sine squared 2x is going to be equal to what number? 1. So all I'm going to have here, I'm going to write cosine squared 2x minus, still not how I wanted to do it. And you know what? Oh man, was it going to let me? No. Okay, what I wanted to do was I wanted to put my 2x in parentheses. I don't know if it's going to make a difference or not. I don't think it will.
This doesn't work with anything odd, right? Like if you have a 2, does this work?
No, because remember, my formulas for the difference of squares, right? So they have to be squares, right? So my powers, John, have to be even powers. They got to be 2s, 4s, 6s, 8s, so on and so forth. Okay, so Pythagorean identity right here. And let's see, validate. Okay, and then this right here is going to be equal to the cosine of 4x based on the double angle. So where's my double angle? Boom, there we go. Right? So guys, I'm going to come back so you can see what I'm doing. So when we get to this step right here, I probably forgot a 2. This step right here is that when my theta is equal to 2x, right? So I'm just using that double angle formula, okay? And so I'm going to come back one more time, and I'm going to validate it. Your proof is complete. Let's check it. Hopefully they don't give me any grief. There we go. What's up? Guys, message me, right? So Thomas messaged me. What time was it last night? 10:30, right? Guys, when you guys message me, all my Pronto is on here, okay? It's not on my phone, it's on here. So I keep this in my bag, right? So it stayed in my bag last night. When I got up today, I checked it. Thomas had a message for me. He's like, hey, I'm sorry for messaging you so late. You can message me at 4 o'clock in the morning. It ain't gonna bother me. I'm asleep. I got this in my bag. It's in the other room.
And I didn't message you because for some reason I've been stuck on hold for a while. So I keep getting sine and tangent wrong. Cosine, I get it right, but
the sine and the other part you're getting wrong. Message me, guys. This is why I'm here. This is why I'm using Pronto. Okay, not like I'm not required to use Pronto, right? It's just another. Another method of communication that we have, right? There's some people in our department that like send me an email. It's like, oh my God, how are you going to send this stuff in an email, right? You can either write it out, take a picture and send it, but it's much easier when, like Thomas last night, he took a screenshot of the actual problem, right? You cropped it out and everything. It was
literally the same thing you did with before, except I used it with the shortcut, and I just cropped the.
So he messaged me, right? So send it to me, guys. I mean, all my classes, this is what they do, right? They send me messages on Pronto. So I'm trying to think, do I have any? Let's see. So yeah, I have some other messages here. So I'll get to them later, right? Not from our class, but from other classes. But like today, I made Thomas's video, and then I made one for my stats class, right? And when one person asks me, I don't say, hey, everybody, like right now, because Thomas said, hey, he was the one who asked me the question. So, we're talking about it. But I never say, hey guys, Thomas asked me this question. I just said, hey, somebody asked this question. I do that for all my classes. So that even if you haven't gotten to that problem yet, you'll probably get there at some point. And then you might say, hey, you know what? Mr. Rodriguez sent a video out. Let me see what it's all about. Oh, okay, let me see if I can apply that to this one. Guys, the other thing I was telling my class, I was actually telling them last night. I don't know if you guys know this, but somebody said, sir, you sent us a video, right? I get it on my phone, and it's really hard for me to watch this video on my phone that's this big. You don't have to watch it on your phone that's big. Click on the Pronto thing right here. It's in Blackboard. And let's see. So here we go, right? Here's the verifying double trig identity. And it pops up right here. Yeah, sorry. And there it is, right? So you're watching it on your laptop instead of trying to see it, you know what I mean? On your phone screen, right? So again, you have it on there, so don't be nervous about using it, okay? All right, so look, let me stop sharing this and let's get back to our notes. So let's see, what are we doing today? Oh man, where's my weekly? Yeah, we're just gonna do 5.4. This is us right here. Oh man, where's 5.4? Here we go. Here we go, here we go. Let's print this thing. I'm going to send it to OneNote. Here we go. Yeah, this right here is good. This is more college algebra. I guess I'm trying to get in this one, but that's okay. Huh? Yeah, week 6. Yeah, but I mean, like this is all of chapter 2's notes. It's not like one. You know what I mean? Yeah. See, like I'll put it this way. Man, where's our notes? Why the hell did this thing open up somewhere? Let me see. Let me try one more time, guys. Let's try this because I don't know where it is. Let's see. I thought I was going to open up right here, and I don't see it. This is all over the place. Let's try this. Let's try this one more time. Is this thing freezing up on me? Let's see if it opened it up in here. Yeah, this is all one chapter. This is not different sections. Let me close that up. Not necessarily. So we all got to cover the same material, right? We all have to cover the same material, but how you do it is kind of up to you, right? So somebody else who's teaching pre-cal, may decide that they're going to cover certain topics more or less than what we're doing. You know what I mean? So it all kind of varies. I don't necessarily think that's great, but that's what it is. So, okay. All right, anywho. So guys, today what we're going to do is I'll make sure I'm still sharing this one here. So it's coming out in the video. Yes, it is. Okay. So today what we're going to do, y'all, we're going to do section 5.4. And so in 5.4, we have these things called, product to sum and sum to product formulas, okay? So again, I'm going to try to go really slow and see if I can't make sense out of some of this stuff, and let's see if we can make this thing work. So guys, one thing I'm going to do also here is in our, here we go. I'm going to pull up this fundamental trig identity handout because I think it's going to come in helpful as I'm doing some of these problems here, okay? So let's take a look at the first problem, and it says verify the identity that the sine of u plus v plus the sine of u minus v is equal to the sine of u cosine of v. Okay, so let's see if we can do that. First thing I'm going to do, y'all, I'm going to leave this 1/2 alone. I'm not going to mess with it just yet. Okay, and I'm going to look at this point, the sine of u plus v. So I want to say that in that formula sheet right here, we have a formula for the sine of u plus v, right? And it's right here. It's the sine of u cosine v plus cosine u sine v. So let's go ahead and fill that in. So this is going to be sine u cosine v plus cosine of u sine of v. So far, are we okay? How we got to where we are? I'm just applying that sine of u plus v formula, right? All right. Now, huh? You can do that too. Okay. So now look, I'm going to do the same thing for the sine of u minus v, right? So guys, I'm going to come back one more time, and I'm going to say, look, there's one for the sine of u cosine v. So it's sine u cosine v minus cosine u sine v, right? So notice the only difference between the two is if we have a plus in the middle, we have a plus in the middle here, right? If we have a minus in the middle, we got a minus in the middle here. So I'm going to write this as plus sine of u cosine of v minus cosine of u sine of v. Okay. Now, let me ask you a question. Do we have any like terms here? Which ones are like terms? Okay, so cosine u sine v, this one here, y'all, and this one here. If one is positive, one's negative, what's going to happen to them? Cancel out. Okay, so let's get rid of those. Okay. Another question. Are these also like terms? So we're going to have a 1/2. Now, when we have a sine u cosine v and another sine u cosine v, isn't that going to give me 2 sine u cosine v? And then what's half of 2? Half of 2 is what? Half of 2 is 1, right? So those 2's cancel. We end up with sine u cosine v. Isn't that what they had on the right side? Right? Well, yeah, so what they're asking me to do, they're asking me to prove, let me see, what was it? Which one did we have? We had sine u cosine v. So they're basically asking me to prove that identity, right? Can I prove that, right? Because that's really what I'm, so this right here, it's just written backwards, right? So they're asking me, can you really show that this trig identity is really, really going to work? And that's why I was using that, the cosine of the sum and the, and sine of a difference angles, right? Because that's essentially what's going to happen. I'm sorry? Prove that this really does work, right? Yeah, that's all it is. Okay. So guys, let's go to number 2, and I'm going to try to apply the same principles that I have here, okay? So I want you to notice something here. It says, look, write the product as a sum or a difference. So first thing is, I'm looking at this part right here, cosine of 8x, sine of 5x. So what I really want to do is when I'm looking at my product of sum formulas, I want to stare and compare this to those, right? And say, okay, my number 2, which of those 4 little formulas does it look like we're going to use? Think about it this way, guys. 1, 2, 3, 4. Which one are we going to use? The 4th one, right? Okay. So if we're going to apply this this formula right here, what would my u be, and what would my v be? Okay. There you go. Okay. And we said we're going to use this, the 4th one over here. So we're going to write like this: 1/2 sine of, look what it says, u plus v, 8x plus 5x, minus, because there's a minus right there, sine of u minus v. What's 8x minus 5x? Well, we'll just write it out. and then we'll get to that part in a second. And all of this is in brackets, right? So now this is going to be equal to 1/2 sine of, what's 8x plus 5x? 13x minus, what is 8x minus 5x? And you are done. You got it. Why is this thing blinking here? I was just getting back over here. Guys, one thing I want to point out as well, if I come back to my formula sheet, I'm sorry? Okay, what did the problem ask us to do? It just said write it as a sum or a difference. This is a difference, right? Because the difference means you are subtracting. Yeah, that's all it's asking me to do. Just write it as a sum or a difference. So we did, right? Okay, so guys, one thing I want to mention. Look, I'm going to pull up my identity page, the formula sheet. So those formulas are also in your formula sheet already, okay? So they're already there. Again, you don't have to worry about hunting for all these things. Try to put them all in one easy to find spot, okay? Guys, like I told you all the other day, when you're between now, remember next Wednesday, all we're gonna do is just what? Work out review problems from the review. So between now and next Wednesday, you know, you want to be working on the review. If there's any questions that come up and you're like, hey, you know what, I needed this formula and it's not on the formula sheet, let me know. I'll throw it on there, okay? I'll update the formula sheet, all right? All right, so let's come back to the next problem. So we're going to do the same thing here again. We're going to write this as a sum or a difference, okay? So look, I'm going to look at my problem right here, and I'm going to pull up that formula sheet, okay? So look what we have. We have cosine 2x, cosine of negative 5x. According to my formula sheet, which one should I use? 1, 2, 3, or 4? So let's come back. Let's double check just to make sure. Cosine and another cosine. Which one should we use? 1, 2, 3, or 4? 3. This one down here, right? So it's going to be 1/2 cosine of u minus v plus cosine of u plus v, right? Okay, so I'm really using, oops, I don't think it's going to let me do it. Well, I can't write on here, but I'm going to use this bottom, this one right here, okay? So let's come back. In this case, guys, what is my u and what's my v? So 2x, and then our v is a negative 5x, right? Okay, so let's copy it down. Now I know we have a 1/2, and then I'm going to come back to my formula, cosine of u minus v. Okay, so cosine of u minus v. Okay, so cosine of 2x minus a negative 5x plus cosine of u plus v. Cosine of u plus v. Okay. First question, 2x minus a negative 5x becomes positive. So 2 plus 5? Okay. 2x and a negative 5x? Minus negative 5x, right? And minus minus becomes positive. So what's 2x plus negative 5? Negative 3, very good. And I know it feels like we're kind of still out there, but we're done. Right. Guys, at this point, the only other thing that I would consider doing is I'm going to come back to my formula sheet, and it's right here. Do you see how we have these even and odd identities? Look what it says here. If we have the cosine of negative x, it's just the same thing as the cosine of x. So if anything, what I would do here is I would say, I would probably rewrite this as, I'll write it over here. I'd probably just rewrite this as 1/2 cosine of 7x plus the cosine of 3x. Because if I have a negative on the inside, right, with my, sorry, if I have a negative on the inside with my cosine, what happens to it? It just pops out, right? There's no negative there. Now, look, see how we have the negative here? Okay, is there a negative in front? No, right? So I'm not going to put a negative in front over here either, John. Right? So remember, the negative doesn't come out. It just goes away because it's an even function. That would probably be the only thing I would do. All right. So guys, I'm going to keep working here. And look at the next problem here. It says, use the product to sum formula to find the exact value of the sine of 5 pi over 12 and the sine of pi over 12. What do y'all think the first thing I'm going to do here is? I'm sorry, before I even do my u over v, let's convert them to degrees, right? So guys, remember this is what we've been doing so far. If I see something that's, you know, it's not like, if it's not like 0, pi over 2, pi, 3 pi over 2, or 2 pi, I'm going to convert it to degrees because it'll be easier for me to understand, right? 5 pi over 12, you said times 180 over pi. And you said this came out to how much?
No, I just know that pi over 12.
Oh, pi over 12. Okay, I'm
So
sorry.
it'd be 5 times 15.
So let's see. Oh, I canceled out the 5 and I don't want to cancel that. I don't want to cancel out the 5.
I think it'd be 3 things, because I remember it goes
Yeah.
in.
Okay, so 12 goes into 18, what, 15 times? And 5 times 15 should be 75 degrees. And then pi over 12 times 180 over pi, those cancel, this goes in 15, so this one here is 15 degrees. Okay, so what we have now, y'all, we have the sine of 75 degrees and the sine of 15 degrees, right? Okay, so let's take a look again. I'm going to look at this piece right here. We have sine and we have another sine, right? So I'm going to come back to my, here we go. Look at those formulas, y'all. Should I use formula 1, 2, 3, or 4? 1. This is what we're going to write out. We're going to write out 1/2 cosine of u minus v, cosine of u plus v. Okay, so we're going to use the first formula. Do y'all know what's my u and my v in this problem? There you go. Okay, so let's do this to this. We're going to have 1/2 cosine of, what was it? U minus v. Okay, so we're going to write 75 minus 15. And then, minus cosine of u plus v. Okay. What's 75 minus 15? 60? And 75 plus 15? 90? Okay. So far, are we doing okay? All right. Guys, I'm going to pull up that formula sheet one more time. Here we go. Okay. So we want to know what's the cosine of 60 degrees. The cosine of 60 degrees is how much? 1/2. Okay. So right here, we're going to say this is 1/2 times cosine of 60. We said it was 1/2 minus. Anybody know what the cosine of 90 is? You guys remember the cosine of 90 is up here. So this is 90 is the same thing as pi over 2. But remember, think about my hand as being a distance of 1. So this point here, when my fingertip on, this is the point 1, 0. So x is 1, y is 0. What would the coordinate be this point? 0, 1. What's the x coordinate here? 0. So the cosine of 90 degrees for pi over 2 is 0. So right here, we're going to put a 0. Okay. We're almost done. This is 1/2 times 1/2 minus 0 is still 1/2. What's a half times a half? 1/4. You got it. Right? You got it, did. Okay. So guys, the one thing I want to point out about these problems here, what's really, really, really helping me is being able to go back and reference those 4 formulas, right? And then the other thing I think is going to be super helpful as you're doing these problems is making sure that I have that there, right? So that I can reference those things. And then guys, I know we didn't have like the 90 and the 180, but remember, I'm thinking about that unit circle, right? Where the ends of my fingertips are a distance of 1. So this is the point 1, 0. This is 0, 1. This is -1, 0. This is 0, -1, back to 1, 0, right? Got it? Good, good. Okay, so let's take a look. We got another problem here. And it says, let's verify this identity, that the sine of x plus y times the cosine of x minus y is equal to the sine x cosine x plus sine y cosine y. Okay, so guys, the one thing I really want to emphasize here, look what we're trying to do. We're trying to show that this side is the same as that side, right? Do we have a formula for this? Okay, so let's come back and let's access that formula, right? So look, let me come back over here. And John, I know you don't like the formula because it uses u's and v's, but in our problem, we're using x's and y's, right? Okay, so look, I'm going to use the sine of u plus v, sine of u cosine v plus cosine u sine v, right? So I'm going to use this first formula right here to do that part. So just to come back and double check, what does it have? Sine u cosine v, so it's going to say sine x cosine y, and then plus okay. And so I'm going to put all of this right here, y'all, in parentheses, because we are going to multiply it, right? Okay, then we're going to do the same thing for cosine of x minus y, right? So if I'm going to go cosine of x minus y, that's going to be this one over here. So it should be cosine x cosine y plus sine x sine y. Okay, cosine x cosine y plus sine x sine y. Okay. Okay. Now, like John says, to multiply. So guys, remember the other day, Thomas had brought up the full method? That's what we're going to do. Remember the first, outer, inner, last, right? Okay. So we're going to go slow. Look, we're going to take this piece here times that piece there. So there's only one sine x, so I'm going to write that down, sine x, okay? There's only one cosine x, so I'm going to write that down again, okay? But look, we have a cosine y and another cosine y. What is that going to give us? There you go, cosine squared y, right? Okay, so hey, we got the first ones done. Let's do the outer ones. So I'm going to do this piece here and that piece over there. So look, we have a sine x, we have another sine x. Isn't that going to be a plus sine squared x? Okay. And we have a sine y, so I'm going to go ahead and write that down. And we also have a cosine y. So I'm going to write that down. Okay. Well, we got rid of the outer ones. Okay. So remember, so hold on, let's go slow. One piece at a time. Sine x and another sine x is going to give me what? There you go. Now there's only one sine y, so I wrote it down. And there's only one cosine y, so I wrote it down. Right? You see what I'm doing now? Yeah, let's go. The faster I go, the more mistakes I'm going to make, right? So I'm trying to go slow motion for me, right? Juvenile. Y'all probably don't know that song, but it's there. Look, cosine x and another cosine x. What's that going to give me? There you go. So look, plus cosine squared x, right? Okay, we have a sine y and a cosine y. So I'm going to write a sine y and a cosine y. Okay, those are the inner terms. Okay. Now we got to do the last ones. So cosine x sine y and sine x sine y. So y'all agree we're going to have a sine squared y? And then we're going to have a cosine x and a sine x? Okay. All right. Now, I don't know if anything's going to cancel, but I hope something will. So let's take a look. Let's see. Let's see. Okay, you know what we're going to do? We're going to see if we can put some stuff together. Okay, so look, yeah, guys, I want y'all to notice this piece right here. Let me get the color that I haven't used before. Do you see how this has a sine y, cosine y, and this also has a sine y and cosine y? Those really are like terms, right? Because they both have sine y, cosine y. So before I do anything else, I'm gonna pull something over here on the side. I'm gonna make this up. Suppose I had 5 sine y, cosine y, plus 7 sine y, cosine y. What would you say the answer would be? Almost. Not 13. Not 14 either. 12. You would say this is 12. It's okay. Sine y, cosine y, right? Let me ask you a question. How did you get 12? I know you know the answer. So how did you get 12? What did you do? You added those numbers in front, right? Okay, we're going to come back over here to our problem. These are like terms. What are we going to do? Well, hold on. Look at the numbers in front. I circled them for us. One of them in front is a sine squared x. The other one in front is a cosine squared x. So hold on, wait. We're not going to even make it that hard. We're going to go like this: sine squared x plus cosine squared x, and that is what's in front of my sine y, cosine y, right? I'm just putting that in front because just like we did before, the way you came up with 12 was you said, I'm really adding 5 and 7. So I'm really adding that sine squared x and that cosine squared x, okay? Now, we're going to get that, yeah, we're going to get to that part in a second. Now, let me ask you another question. Look at this piece here and look at this piece here. Are they both, let me see. Yeah, but I'm trying to think. Yes, cosine x sine x, cosine x sine x, right? So those are also like terms. So just like the way we did before, we're going to add what's in front of them. So we're going to say this is a plus cosine squared y plus sine squared y in front of our cosine x sine x. Okay. Okay, going super slow here, guys. Thomas said this a little while ago. Y'all remember what's sine squared x plus cosine squared x? That's 1. So that's going to be the number in front of my sine y, cosine y. So I'm just going to put a sine y, cosine y. Isn't sine squared x plus cosine squared x the same thing as 1?
Okay.
So that's the number that's now in front of my sine y, cosine y, right? And isn't that going to be the same thing here? So that's going to be the number that's in front of my cosine x, sine x. Right? And is that what we had on the other side? It's just switched around, but it's the same deal, right? We had that right over there is what we have right over here. So, guys, before I go on, I want to point something out about this problem. Let's do a little recap on this problem. What was the first thing we did? We said, look, if I have the sine of a sum and the cosine of a difference, I'm going to use those formulas. And all I'm going to do is I'm just going to write out what they are in terms of using the formula. Then we have parentheses here and parentheses here. So let's multiply. Guys, if you notice when we multiplied, we went slow, right? I was not trying to rush through. And if you get worried or get confused, like how do I actually multiply this out? Just say, look, you're going to take this piece and that piece. Well, here, there's only one sine x, so I wrote it out. There's a cosine y and another cosine y. That gave me a cosine squared. And I still had this guy right here, the cosine x, right? And I'm just going real slow. I'm not trying to, don't think too far ahead of what the answer is going to be. Just write it down, right? Just write it down and it's going to work out, right? And I'm going to give you a hint. Look, I'm going to show you one way that you can, again, especially if you struggle with how do I multiply all these different pieces out. I'm not saying that you do struggle, but in case you do, I'm going to take the last ones. Cosine x, sine y, sine x, sine y. So if I was doing that here, cosine x, sine y, and, oh man, I already forgot what it was, sine x, sine y. Okay. The first thing I would say is, look, that and that's the same. And the order in which you put them in makes no difference at all. And now you got it, right? Because you're multiplying, right? So remember, when you multiply, which one you put first or second doesn't make any difference, right? If I ask you, what's 2 times 3? You tell me the answer is 6. And if I said, what's 3 times 2? Still 6, right? It applies to this as well, right? It applies to these kind of things as well. Commutative property says you don't got to do, doesn't matter which one you do first or second. Now, guys, the one thing I want to emphasize is you're right, it doesn't matter. But sometimes when you see like a sine x, cosine y, and over here you see a cosine y, sine x, sometimes they don't look the same. You got to be able to recognize that they really are, though, right? The order in which you write them is not important. X times y and y times x is the same thing, right? So the same thing applies for cosine x, sine y's, and that kind of business too. Okay, so yeah. So let's see, look, we only got, there's just a couple more problems to do. I think there's 3, 4 more problems to do. Let's knock these out. We can do these. Okay. Write it as a product, okay? So I want you to notice these formulas are called either product to sum or sum to product formulas. So it's telling me to write it as a product. A product means we're going to be multiplying. And right now, what are we doing with those two things inside? We're adding them. That tells me I'm going to use the sum to product formula. So let me ask you a question. I'm going to go like this. 1, 2, 3, 4. What formula do you think I'm going to use? 3. Okay, so guys, y'all agree here that in this problem, our x is the 5 beta and our y is the 6 beta? Okay, so we're going to use formula number 3. So we're going to write 2 cosine of 5 beta plus, I'm sorry? Yeah, so because they're both betas, right? But yeah, that's exactly what I'm going to do. All I'm doing really here, though, Thomas, I'm just plugging them into the formulas exactly as I see it. I don't want to try to go too fast. Is that what you're asking about?
No.
I'm sorry. Who are you?
Why do we even have to do anything?
We're just going to prove.
Because we're really just going to write it out. You see what I mean? I'm going to write it out using that part. Does that make sense? Good. And then cosine of, what is it, 5 beta minus 6 beta over 2. And so this is going to be 2 cosine of, what's 5 plus 6? 11. And 5 minus 6? Negative 1. Good. Guys, y'all agree with me that we can drop that negative sign inside? Because when cosines, we have that cosine of an even function. Says if you have the cosine of negative x, it's the same thing as the cosine of x. So the cosine of negative beta over 2 would just be the cosine of beta over 2, right? That's all we're doing here. Okay, so let's try number 7. We're going to go about it exactly the same way. So let's take a look-see here. It says write it as a product. The sine of x plus sine of 3x. Using my formulas up there, y'all, what formula would I use? 1, 2, 3, or 4? 4, okay. Boom, this is one we're going to use. What is our x and our y in this problem? X is just x, and y is a 3x? Okay. So we're going to put a 2 sine of x plus 3x over 2, and a cosine of x minus 3x over 2, which is, let's see, what's x plus 3x? 4x over 2, and x minus 3x is negative 2x over 2. Okay, we're almost done. 4x divided by 2 is just a 2x, right? And then this one over here is going to be the cosine of a negative 1x. And then can't we get rid of that negative inside as well? All right. So guys, let's try number 8. It says use a sum to product formula to find the exact value of cosine of 13 pi over 12 minus cosine of 7 pi over 12. Again, just like we did earlier, what do you think the first thing we should do here is? Convert. Okay, so let's do it to it. Well, but hold on, we got cosine of 13, I'm sorry, we're going to take 13 pi over 12 times 180 over pi. So again, I know that my pi's are going to cancel. 12 goes into 180 15 times. Anybody know what's 13 times 15? 195. Okay, perfect. And then let's do the same thing for 7 pi over 12, right? So 7 pi over 12 times 180 over pi. That goes in 15. And 7 times 15? 105. Okay. So really what we're going to do here is we're going to say, what is the cosine of 195 degrees minus the cosine of 105 degrees? Okay. So sum to product rule, is that what we were dealing with here? Yes. Okay. So guys, if you look at what I have here, we have the cosine of one angle minus the cosine of another. Which one of those formulas do you think we would use? The first one, right? Okay, so guys, I am going to zoom in on the first one. I want you to notice, what do we have right in front of that first one? A negative 2. Okay, so I don't want to forget my negative there. Okay. And then, let me ask you another question. What is my x and my y? You got it, my friend. Okay, so we said negative 2 sine of, let me come back and look at the formula again, x plus y over 2. Okay, so 195 plus 105 over 2, and then what's the other part of it? Sine of x minus y, though? Okay, good. Sine of 195 minus 105 all over 2. Okay, so let's keep working here. This is going to be a negative 2. What is 195 plus 95? 2, how much? 300? Okay, so 300 over 2. Okay. Well, I'm going to do this. I don't want to skip any steps because when we do, that usually kind of gives us some problems. So I'm going to just take my time with it. 195 minus 105 is 90 over 2. Negative 2. Sine of, you said 300 over 2 was 150. 90 over 2? It is 45. Okay. What am I going to do now? And come back to my little chart, right? Boom, let's find it, let's find it, let's find it. Here we go. What is, and I got it up here for y'all so y'all can take a look. If you want to, you can use your own. What's the sine of 150? 1/2. So let's write that right here. So we have negative 2 times 1/2. What's the sine of 45? Positive or negative? For 45 degrees. Positive, right? Square root of 2 over 2. Okay. So, guys, I'm going to go real slow. I'm going to think of this as being over 1. Okay, I'm going to multiply the bottom. What's 1 times 2 times 2? 4. On the top, negative 2 times 1, negative 2, square roots of 2, like this. Okay, y'all agree that we can reduce the 2 and the 4? So we end up with a negative square root of 2 all over 2. I don't know about you guys, but I'm glad I have that right there. Because that just makes it so much easier for me to do, right? I'm not having to think about it every single time, right? And can I use my calculator? Of course I can use my calculator, but just having this as a reference, easy for me to look at every single time, right? Okay. All right, so it looks like we got one last problem to do here. And it says, use a sum to product formula to find the exact value of sine of 165 minus 105. Okay, so guys, formula 1, 2, 3, or 4? 2. Okay, what is our x and what's our y? And 105 is y? Okay, so let's take a look at what the formula says. The formula says 2 cosine xy plus 2 sine of x minus y over 2. So 2 sine of 165 plus 105 all over 2. And then it's minus, or sorry, then cosine of the minus. 165 minus 105 all over 2. So let's see. This is going to be 2 sine of, what's 165 plus 105? 275? Shouldn't be 270? Okay, 270 over 2. Good, thank you all so much. Let's see. Cosine 165 minus 105 is 60 over 2. Okay. Anybody know what's half of 270? 135? And I bet you already know that half of 60 is, you knew that already, right? Oh, is it? Oh, cosine and then sine. Oops, my bad. My bad. Sorry about that, guys. Let's fix that. Okay, so cosine first, sine second. Let's fix that. Yeah. Erase, erase. Erase, erase. Cosine first, sine second. Same thing over here. Thank you, Thomas. I would have made a big mistake here. Cosine first, sine second. Okay. All right, now we're almost done. So there's a 2 here, so I'm going to write it. I'm probably going to think of that 2 guys as 2 over 1. Let me come back to my formula sheet. What's the cosine of 135 degrees? Cosine of 135 is negative square root of 2 over 2. So we're going to say this is a negative square root of 2 over 2. Sine of 30 degrees is 1/2. Good. Guys, just like we did earlier, I'm gonna just go straight across. Let's do the bottom parts. What's 1 times 2 times 2? Good. On the top, 2 times the negative square root of 2 is a negative square root, or negative 2 square roots of 2. And then I'm just gonna reduce my 2 and my 4. So that becomes negative square root of 2 all over 2. Okay. So guys, let me ask you all a question. In doing problem number 9, didn't we do number 9 the same way we did number 8? The only difference is that number 8, it was given to me in radians, so we first converted it to degrees, right? And then we applied their formula. But number 9, it was already set up for it because it was already in degrees, right? So again, to me, understanding degrees is so much easier because otherwise I'm trying to figure out how am I going to do this applying to the radians, and I've got to do a whole lot of common denominators and all that kind of nonsense. And our chart, we have it in degrees. I mean, you can convert them to radians if you want to, but that's just an extra step that you got to do. I would much rather deal with degrees because I can figure them out a lot easier, right? All right. Did that make sense on what we did today? A little bit? From degrees to radians? So how are we going from radians to degrees? What are we multiplying by? So now you're going to multiply by, boom, and you got it. Okay. Okay, so guys, on Monday, we're going to finish up chapter 5. There's one more section of chapter 5 we got to do. We're going to worry about doing that on Monday, okay? Remember, next Wednesday, all we're going to do is work on the review. That's it. Nothing but doing the review. So again, between now and next Wednesday, try to do as many of those review problems as you can so that when you come to class, we can say, hey, look, how do I do this problem? How do I do that problem? That kind of setup, okay? Guys, like we were talking about earlier, let me stop sharing this and let me stop recording because we don't need to record anymore. But thank you, Jen.